In this lesson, we're looking at inscribed angles, and this is going to include intersecting a diameter as well as overlapping arcs. So let's go ahead and get started. Now, what is an inscribed angle? Well, an inscribed angle has a vertex on the circle and the two sides are chords. So we can see our vertex B here that is on the circle, and sides A, B, and CB are chords. Remember, chords have endpoints on a circle. And we have an intercepted arc here. So this is arc AC right here. And so let's look at our property here. The measure of the inscribed angle is equal to half the measure of the intersected arc. So the intercepted arc here is arc AC. And so the measure of angle ABC is 1/2 the measure of arc AC. So now let's use this knowledge here to work out some problems. So let's take a look at our first 3 examples here. Number 1, it says the measure of angle WXY. So right here. Okay. So we have the arc, intersected arc of WY is 62. So remember, the inscribed angle is just half of that intercepted arc. So I'm going to say half of 62, which is arc WY, is 62. I just take half of it, that is 31. So 31 degrees, or you could just divide 62 by 2 to take half. So the measure of this angle here is 31 degrees. Let's look at number 2 here. We have the inscribed angle. So if the inscribed angle is half of the intersected arc, so we want to find arc DGF, that means that the intersected arc is double the inscribed angle. So if DEF is 113, I could just multiply 113 times, let me use a dot for my multiplication, times 2. That gives me 226 degrees. So arc DGF is 226 degrees. All right, so our last one we want to try here, it says solve for x. So I have angle CDE right here, and that is 8x minus 9, and I have the intercepted arc is 58 degrees. So that intercepted arc is double the amount of angle CEF. So if I multiply 8x minus 9 times 2, I could set that equal to 158, or I could take half of 158. I'm going to take half of 158, but either way. So 158 divided by 2, that gives me 79. So I could set up the equation. 8x minus 9 is equal to 79. Adding 9, so it's just a 2-step equation, and then dividing by 8. So x is equal to 11, or I could have set up this equation. I'm not going to completely work it out, but you're going to get the same answer. I could have done this. 2 times 8x minus 9 is equal to 158, and that would have given me the same answer. Well, actually, you know what? I'm going to go ahead and work it out since I've already gone through the troubles of writing it down and adding 158 is equal to 176, and then dividing by 16, and of course I get 11. So either way, you're going to get the same answer. So the next few problems I'm going to ask you to try on your own. Alright, so I would like for you to pause the video and try these problems on your own. So go ahead and check your answers here. Number 4, you should have gotten 86 degrees. Number 5, 121 degrees. And number 6, x is 19. Notice I worked it out both ways, so hopefully you got it correct. If not, just pause the video here and analyze my work just a little more. So now we're looking at intercepting a diameter So if an inscribed angle intersects a diameter, then it is a right angle. So we have the diameter here is BC, right? Our diameter is right here. So if the inscribed angle intersects a diameter, it is a right angle. So the measure of angle BAC is equal to 90 degrees. And so right here we could put a 90-degree angle. All right, so let's look at these two problems here using intersecting a diameter. So we want to find PQR. Since PR is a diameter, then PQR would be a right angle. So PQR would just be 90 degrees. Let's look at number 8 here. It says if the measure of angle KJL is 3x plus 2. So I like to label everything. So that is 3x plus 2. And KLJ, that is 7x minus 32. We want to find arc KL. So we want to find this arc right here. So now, since we have a diameter here of JL, the measure of angle JKL is 90 degrees. So I can put a 90-degree angle here. So now we know that there are 180 degrees in a triangle, right? So if this is 90, my other two angles together, so KJL and KLJ would be 90 degrees together. So I could set up the equation here. 3x plus 2 plus 7x minus 32 is equal to 180. Combining my like terms, so again algebra, and then 2 and negative 32, 180. Solving this two-step equation here, it should be 30. So 10x is equal to 120. So x is 12. So we found x. But I want to find a measure of KL. So I could plug in x into this angle here, KJM. So if I do that, 3 times 12 plus 2. So 3 times 12 is 36, plus 2 is 38. So if this angle here is 38, remember that the arc is going to be, intersected arc is twice the inscribed angle. So if KJL is 38, then 38 times 2 is 76. So we could say the measure of arc KL is equal to 38 times 2. So that would give me 76, and not 726, 76. Because this is double. So KL is 76 degrees. Now we're looking at overlapping arcs. So if two inscribed angles intersect the same arc, then the angles are congruent. And so our intercepted arc right here is arc AD. And these two angles, angle ABD right here, and ACD, intercept the same arc AD right here. So the measure of angle ABD is equal to the measure of angle ACD. They are congruent because they intersect the same arc right here. Alright, so let's take a look at these two examples here. We want to find the measure of angles RST right here and RUT right here. So they're going to be congruent because they interact the same arc RT right here. So if we can find arc RT, we would just take half of it to get the angles here. So I could actually find arc RT. I know there's 360 degrees in a circle, so if I do 360 minus 64 right here, minus 139 right here, minus 75 right here, I get 82 degrees. And so since arc RT is 82, the inscribed angle would be half of that. So I could just divide by 2. That gives me 41. So these two angles here will equal 41 degrees. So RST and RUT are congruent. They both equal 41 degrees. So now let's take a look at number 10 here. It says ABD is 6x minus 26. So I like to label it. So that is 6x plus 26. And then ACD is 13x minus 9. 13x minus 9. Find the measure of arc AD. So I can see here that I have the intercepted or the inscribed angles here. They intercept the same arc, arc AD. So these two angles are congruent because they intercept the same arc right here. So I could just set these two expressions equal to find x. All right, and that would be 9. 6x plus 26. Subtracting 6x, I get 7x minus 9 is equal to 26. Adding 9, 7x is equal to 35. So x is 5. So I could plug it in. So angle ABD right here, I'm going to plug it in. Because if I find a measure of this angle, I could just double it. So that is 6 times 5 plus 26. So that's 30 plus 26. So this angle is 56 degrees. So ABD right here is 56 degrees. That is an inscribed angle. And so the intercepted arc would be double that. So I could do 56 times 2. And that gives me 112 degrees, which is what we want. We want the arc AD. Everything is in red. Let me put it in a different color. So arc AD right here. So if this angle is 56 degrees, then arc AD is double that. That would be 112. So the measure of arc AD is equal to 112 degrees. Alright, so the last few I want you to try on your own. Alright, so the last two problems here I would like for you to try on your own. Go ahead and pause the video and try these two on your own. So you should have gotten 73 for number 11 for both of those angles. And the measure of arc PL is 62 degrees. So hopefully you got the answers correct. If not, go ahead and just pause the video and analyze my work here a little more. Alright, so we've reached the end of our lesson. I want to thank you for learning with me. Some related videos are inscribed quadrilaterals. You're going to use your knowledge of inscribed angles to do inscribed quadrilaterals. Another video is arc lengths in a circle. So if you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.